Number 17. Solve algebraically the system x minus y squared equals to 1 and x minus 3 quantity squared plus y squared equals to 4. So this is a system of nonlinear equations, but we're going to solve this very similar to our system of linear equations. So we have two options. We can either use substitution or we can use elimination, whichever one you like best, or depending on the situation, whichever one will actually work. So here I think substitution or elimination would both work in this case. Elimination may not be as easy, but it would work. So I'm going to go ahead and just use my substitution. So I'm going to pick one of my equations and solve for that variable. So I'm going to go ahead and say x minus y squared equals to 1. I'm going to start with that, and I'm going to solve for one of these. Well, I know I have a y squared in my other equation. So if I go ahead and just solve for y squared, I can get rid of that squared term in my second equation, which would be nice. So I'm going to add y squared to both sides, and then subtract 1 from both sides. So now that I have y squared, the variable I want to substitute out all by itself, I can go ahead and plug it into my second equation. So my y squared will become x minus 1. And I'm going to go ahead and expand or multiply everything out so that I can then solve for x. So this x minus 3 squared will become x squared minus 3x minus 3x plus 9. And I still have plus x minus 1 equal to 4. I'm going to go ahead and combine all my like terms. And then get everything to the left-hand side. So I'm going to subtract 4 from both sides. So then, if we can, I want to factor this, which I actually can't, because my factors would be -1 and -4, so not too bad. So x minus 1 times x minus 4 equals to 0. So then x minus 1 equals to 0, and x minus 4 equals to 0. So x equals to positive 1, and x equals to 4, which is really nice. So then what we want to do is plug these x values into one of our original equations so that we can solve for our y values. What's really nice about this is that it doesn't matter what equation that we choose. Either one of them will give us the exact same y values. Awesome. So I'm going to go ahead and choose the easier of the two. X minus y squared equals to 1. So for x equals to 1, we get 1 minus y squared equals to 1. If I subtract 1 from both sides, negative y squared equals 0. Multiply both sides by -1, y squared equals to 0. Take the square root of both sides, y equals to 0. So at the point 1, 0, my two lines will cross. Well, let's look at x equals to 4. Let's see how this changes things. So this time we're going to have 4 minus y squared equals to 1. So I'm going to subtract 4 from both sides, and then multiply both sides by -1, and then take the square root of both sides. So y equals to plus or minus the square root of 3. So we're actually getting two different y values for this one x. So at x equals to 4 and y equal to the square root of 3, and x equals to 4 and y equals to the negative square root of 3. which is really nice. And these are our three answers. Now we could have done this using our elimination. So for something like that, I would have eliminated my y squareds. So let me kind of scooch over here. So for elimination, we want to get rid of one of these variables entirely. So I see that I can easily get rid of my y squareds by just adding these two equations together, because I have one is negative and one's positive. So when I add these together, I want to make sure I only add like terms. So since I have x minus 3 squared, I'm going to leave that alone and just add x on the outside. And I'm going to do the same thing I was doing before. So I want to expand everything and get everything on the left-hand side and factor. And as you can see, we get the same quadratic equation we got from before. So x minus 1 times x minus 4, which gives us x equal to 1 and x equal to 4. And we would do the same thing. Pick one of our original equations and go back and plug in those x values to solve for our y's. And we'll get the exact same answers, which is really cool. So just look at our equations and look to see which one would probably be easier. Could I easily solve for a single variable and plug that into my other function? Or can I add them together and have a variable completely disappear? Either way, if you do your math correctly, you get the right answers.